Now let's talk about redox reaction. Now redox basically stands for reduction. RED stands for reduction, and OX stands for oxidation. So redox reaction basically is a reaction that involves reduction and oxidation taking place at the same time. Okay, again, redox reaction means reaction that involves reduction and oxidation taking place at the same times in the same chemical reaction. So redox reaction must have both reduction and oxidation. Now certain chemical reaction is a redox reaction, certain chemical reactions are not. Now how do we see which kind of chemical reaction are redox? Now let's look at the example here. Now this example, silver bromide, AgBr, decomposes into silver and bromine. Now in this chemical reaction, you can see that AgBr, silver bromide. Now silver bromide again is an ionic equation because silver is a metal and bromine is a non-metal. So ionic equation means that it consists of positive and negative ions. So you can actually split silver bromide into silver as well as bromine. Now bromine, you know that it is from group 7. Group 7 would form one negative charge of ion. So your Br, in terms of ion, when it becomes ion, it is Br minus. So Br minus, this is one negative, over here would be one positive. So your silver would be plus. Okay, so this AgBr is actually Ag plus and Br minus. Now, so Br minus, let's look at Br minus. Br minus will become Br2. So Br minus, you know that the oxidation state is -1. Okay, so AgBr, Ag plus Br minus. So Br minus, the oxidation state is -1. This is Br2. So Br2, what is the oxidation state? Remember, the oxidation state is the same with the charge of the substance. There is no charge here, Br2, so the oxidation state is 0. So this Br minus, the oxidation state is -1. So -1 become 0. So there is an increase in oxidation state. Increase in oxidation state is actually a oxidation process. Therefore, over here, Br minus is oxidized to Br2. Okay, there should be a 2 here. Br2. Now let's look at Ag plus. Now Ag plus, the oxidation state would be +1. And Ag, the oxidation state is 0 because there is no charge here, Ag. So +1 to 0 is a reduction, is a decrease in oxidation state. And decrease in oxidation state, decrease in oxidation state is a reduction. Therefore, your Ag plus is reduced to Ag. So there is an oxidation and reduction taking place at the same time in this chemical reaction, or taking place together in this chemical reaction. Therefore, it is a redox reaction. Yes. Now let's look at another example here. Magnesium plus water. Actually, this is not water. This is actually steam, H2O gas. H2OL would be water. H2O gas is steam. So magnesium and steam, you get magnesium oxide and hydrogen. Now if we look at the oxidation state, Mg, the oxidation state would be, okay, let's look at the oxidation state. Mg plus H2O, you get MgO plus H2. So let's find out the oxidation state. Oxidation state for Mg would be 0 because there is no charge here. And this one, the oxidation state would be +2 because Mg, you can split it up into Mg2 plus and O2 minus. So the charge is 2 plus, therefore the oxidation state is plus 2. So from 0 to plus 2 is an increase in oxidation state. And increase in oxidation state means oxidation. Therefore Mg is oxidized to Mg2 plus. Now let's look at H2O. H2O become H2. Now this one we don't have to look at the oxidation state, we just have to look at the oxygen. H2O, there is one O here. H2, the O is gone. So there is a loss of oxygen, and by definition loss of oxygen means reduced. Therefore, this is a redox reaction because there is oxidation and reduced taking place together in the same chemical reaction. So this is how to look at whether a chemical reaction is a redox reaction. Look at whether is there any substance that gets oxidized, and then after that look at is there any substance that gets reduced. If the answers of both the questions are yes, then it is a redox reaction. Now let's look at the second page of the Mindmap. This is basically just a repeat of the first page of the Mindmap. Basically, these are the 4 definitions of oxidation and reduction. Now let's look at something called oxidizing agent. Now what is this oxidizing agent? Oxidizing agent basically is a substance that oxidizes other people. Okay, so oxidizing agent, basically oxidizing agent does 2 things. First one, it oxidizes other substance, and the second thing is it itself gets reduced. Okay, you can think of it as rich people. Oxidizing agent is rich people. Okay, oxidizer basically is rich people. So rich people make other people rich. Okay, oxidizes other substance means make other people rich by donating money. And itself, the rich people itself gets poorer. So whenever the rich people make other people rich by donating money, then they themselves, the rich people themselves, would get poorer. So this is how I remember the 2 things about oxidizing agent. Now let's look at the example here. So reducing agent will be the other way around. So reducing agent would be reducing agent reduces other substance, it itself gets oxidized. Let's look at the example here. Cl2 and H2S become HCl and S. So Cl2 is reduced, okay, because the oxidation state, let's look at the oxidation state. The oxidation state here is 0. The oxidation state for Cl here is -1. So 0 to -1 is a decrease in oxidation state, therefore it is a reduction. So Cl2 is reduced to HCl. Now when Cl2 is reduced, there must be another substance that reduces it, that makes it reduced. So the other substance would be H2S. So if Cl2 is reduced to HCl, this one must be the reducing agent. This one gets reduced. So there must be something that reduces it. So the something would be H2S. Why? Because there are only 2 things. There are only 2 things as the reactants here. So if this one gets reduced, this one must be the reducing agent. Therefore, H2S is the reducing agent. Okay, and we know that reducing agent, it itself would get oxidized. Reducing agent itself would get oxidized. Now let's look at what happened to H2S. So since H2S is the reducing agent, H2S must get oxidized. So H2S is oxidized to S. H2S is oxidized to S. Why? Because H2S, in order to become S, it must lose hydrogen. So by definition, loss of hydrogen means oxidation. Therefore, it is oxidized. H2S is oxidized to S. Now, when H2S is oxidized to S, there must be something that oxidizes it. So the something that oxidizes it would be Cl2. So Cl2 is the oxidizing agent. Therefore, Cl2 is the oxidizing agent. So you can see that Cl2 is oxidizing agent and it itself gets reduced. It is consistent to here. Oxidizing agent oxidizes other substance, it itself gets reduced. So Cl2, oxidizing agent, it itself gets reduced. Likewise for reducing agent, H2S is a reducing agent, it itself is oxidized. Alright, let's look at another example. H2 is oxidized to H2O because there is a gain of oxygen. Okay, H2 is oxidized to H2O. That means your O2 must be the oxidizing agent. Because this is oxidized, this is gonna oxidize. So this one must be the oxidizing agent. So O2 is the oxidizing agent here. And oxidizing agent, you know that it itself gets reduced. Okay, and H2 would be the reducing agent. If O2 gets reduced, H2 would be the reducing agent. So it's all about reducing agent and oxidizing agent. Oxidizing agent oxidizes other people, it itself gets reduced. Reducing agent reduces other people, it itself gets oxidized. It's all about this. Just have to take a look at these two examples and try to digest what the everything about oxidizing agent and reducing agent. Now these are the common oxidizing agent. Now when whatever is listed here, it doesn't mean that they are guaranteed they must be oxidizing agent. Sometimes it really depends on the question. But these are the common ones. That means most of the time they are oxidizing agent. Now basically for myself, I only remember these three: oxygen, potassium manganate 7, as well as potassium dichromate 6. These three things are almost guaranteed to be oxidizing agent. So if you see these three chemicals in the question, almost guaranteed they are oxidizing agent. Now bromine. Why is bromine oxidizing agent? Now let's take a look at bromine. When bromine react with other substance, it will become, for example, KBr. So bromine, what is the oxidation state? 0. KBr, the Br. Remember KBr, you can split it into K plus and Br minus. So Br minus, what is the oxidation state? It is -1 because it depends on the charge. So 0 to -1 is a decrease in oxidation state. That means it is a reduction. Now, so Br2 is reduced. That means it must be an oxidizing agent. So this is how I find out whether a substance is oxidizing agent or reducing agent. I just think of it in this way. Br2, after a chemical reaction, it will combine with other substance. It will not remain as a Br2. It will combine with other substance to form a compound, whereby the oxidation state for the Br in the compound would be -1. So there is a reduction, there is a decrease in oxidation state. That means bromine is reduced. And oxidizing agent itself is reduced. So your Br2 is an oxidizing agent. Br2 is oxidizing agent. Okay? So as I said, there is no guarantee, but most of the time, bromine and chlorine, they are oxidizing agent. I think only these three are almost guaranteed that they are always oxidizing agent. So remember these three. The rest, try not to remember. Likewise for reducing agent. For reducing agent, these are the common reducing agent. So reducing agent, I only remember potassium iodide, Ki. It's basically almost guaranteed that it is reducing agent. Potassium iodide, hydrogen, and carbon. You learn about hydrogen and carbon in the metals chapter, whereby they act as reducing agent. So carbon, hydrogen, and potassium iodide. Now let's look at the test for oxidizing agent as well as the test for reducing agent. Now in order to test for whether a chemical is an oxidizing agent or reducing agent, in this case it's oxidizing agent. So in order to test for whether a chemical is an oxidizing agent, we basically can make use of these two chemicals. Okay, aqueous potassium iodide or Ki. So this Ki, its color is colorless. When the color of this chemical changes to brown, that means whatever chemical that you test is the oxidizing agent. Okay, so for example, I have this mysterious unknown chemical by the name of X. I want to prove that it is an oxidizing agent. So what I do is I add it to Ki, and Ki is colorless. So if I add it to Ki, then after that, this colorless change to brown. This colorless change to brown. That means this one is a oxidizing agent. Alright. Likewise, I can use moist starch iodide paper to test whether this X is an oxidizing agent. Moist starch iodide paper is white. If the paper changed from white to blue, that means this X is the oxidizing agent. So I can use Ki, or I can use this moist starch iodide paper. Moist starch iodide paper. I can use either Ki or moist starch iodide paper in order to find out whether a substance, whether an unknown substance is an oxidizing agent. Likewise for reducing agent. So in order to test for reducing agent, I can use either acidified potassium dichromate, which is actually an oxidizing agent. Okay, this one. Or I can use acidified potassium manganate 7, which is an oxidizing agent. So basically, you use an oxidizing agent to test for a reducing agent, and you use a reducing agent to test for an oxidizing agent. Because just now the Ki, which can be used to test for oxidizing agent, this Ki is actually a reducing agent. Okay, you use a reducing agent to test for an oxidizing agent, you use the oxidizing agent to test for a reducing agent. Now let's go back to testing for reducing agent. You use acidified potassium dichromate. It is not just potassium dichromate 6, it is acidified. Acidified means you get your potassium dichromate 6 and then you add some certain amount of acid to it. So likewise, if you have an unknown chemical called Y and you want to test whether it is a reducing agent or not, so you add acidified potassium dichromate 6, and this acidified potassium dichromate 6 is actually orange. Okay, if you add the Y to acidified potassium dichromate 6, and then its color changed from orange to green, that means this substance is a reducing agent. If the color of the acidified potassium dichromate 6 doesn't change or remain as orange, okay, if the color of acidified potassium dichromate 6 remains at orange after adding Y, that means this Y is not a reducing agent. We cannot say that it is an oxidizing agent. It is just that it is not a reducing agent. Likewise for acidified potassium manganate 7, KMnO4. So you can either use this or use this to test for whether a substance is reducing agent or not. And of course for acidified potassium manganate 7, the color change would be purple to colorless if Y is a reducing agent.